Hello Gen Chem students. Today we're going to be doing some solution chemistry, such as calculating titrations, dilutions, and calculating different concentrations, also known as molarities, given certain parameters. So let's go ahead and get started. This first question here asks us, how many milliliters of 4 molar magnesium sulfate could be prepared from 25 grams of magnesium sulfate? So ultimately what we're trying to find is our volume amount here, given a molarity and given a grams amount, which we could easily convert into moles, which we're going to have to do using a molar mass. So let's go ahead and first things first, convert this gram amount into moles. So 25.0 grams of magnesium sulfate over 1, so we're just going to do a placeholder, times, and then we're going to multiply it here by our molar mass. So for every blank grams of magnesium sulfate, we're going to get 1 mole of magnesium sulfate. We can solve our molar mass from a periodic table. It's going to be 24.3 grams of our magnesium sulfate, plus our 32 of our sulfur, plus just 4 times 16, essentially. And we're going to get a molar mass for our magnesium sulfate of 120.3 grams per 1 mole. And so what's going to cancel out here is our grams amount of magnesium sulfate with our grams amount of magnesium sulfate. We're left in moles of magnesium sulfate. But once again, reminder, we're wanting to solve for our volume, but we are given this molar amount here. But really, what does molar amount mean? Well, we know that molarity is equal to moles per liter, or per moles per 1,000 milliliters. So what we can do is you can utilize this given amount either way. You could put moles on the top or you could put moles on the bottom. Well, if we want our moles here to cancel to give us our volume amount on top, we're going to have to put our moles in our bottom. So for every 4.00 moles of magnesium sulfate, we will have, and ultimately it wants the answer in milliliters, so we'll just say per 1,000 milliliters. And these two will cancel out. Our molar amount here will cancel out with our molar amount here, and we'll be left in milliliters, which will be our answer. So we're going to go ahead and calculate that through. So 25 times 1,000 all over 120.3 all over 4 gives us 51.95 milliliters of our magnesium sulfate, essentially, of our solution. And that will be our answer to that one. Let's go ahead and drop down to the next one. It asks us how many milliliters of a 12 molar solution of hydrochloric acid is required to make 500 milliliters of 1 molar solution of hydrochloric acid. Now we know this is going to be a dilution one because both solutions are hydrochloric acid. So essentially we're adding some amount of solution or water, some sort of solvent, to dilute a very concentrated, for instance 12 molar, to a more diluted concentration of 1 molar. So what's the key equation we know we're going to need for this one is M1V1 equals M2V2. You might also see it as MC for concentrated, VC for concentrated equals MD for diluted, VD for diluted. Really, they both mean the same thing. So, and then from there, you really just plug in values, making sure you're keeping track of your units. So, we know that the concentrated one is going to be here on our left. 12 molar is going to be our first M. And it's asking how many milliliters of that 12 molar. So we know we're really going to ultimately be solving for this VC here. Is equal to, and we know it's 500 milliliters as our final volume with 1 molar. So we plug those values in here, 1.0 molar per 500 milliliters. We rearrange to solve for our VC. VC is equal to 12.0 molar all over 1.0 molar. Pardon me, we actually rearrange it this way. We do 1.0 molar times our 500 milliliters all over our 12.0 molar. And then our units of molarity will cancel out and we'll be left in units of milliliters. So our VC will then be equal to, and we just do the quick math on that, so 1 times 500 all over 12, and we are going to get 41.67 milliliters as our answer. All right, let's go ahead and do the next one. Calculate the molarity of sodium hydroxide solution if 25.37 milliliters react with 10 milliliters of 0.15 molar sulfuric acid. And it gives us this very important piece of information, which is our balanced equation. Now, on your guys' exam, you might not be given your balanced equation during a titration reaction. How do we know this is titration? Well, my best bet for you is going to be that this is a base. And is sodium hydroxide a base? Yet a strong base? Yes, it is a strong base. Reacting with an acid, and this is sulfuric acid. And this is this going to be a strong acid? Yes, it is. It's one of our 7 strong we memorize, as well as sodium hydroxide is one of our 8 strong bases that we memorize. And if what happens when a base and an acid react together is it is a neutralization reaction, a titration reaction, where this base is going to essentially cancel out, quote unquote, our acid to produce a water with its salt. So, let's read this one more time. Let's see what we're trying to figure out. Calculate, okay, so we're trying to solve for the molarity of our base given its volume amount reacting with a volume amount with a molar amount of our acid. So, when approaching a titration, I'm going to recommend you always start with the piece of information where you have 2 pieces of information on it. So in this case, it's going to be our acid. We know its volume and we know its molar amount. So, and once again, we know that molarity is equal to moles per liter or per 1,000 milliliters. So we know that our molar amount here can cancel with our volume here to be in moles, which we could then use our molar ratios here to solve for the moles of sodium hydroxide, which will then divide by the volume amount we were given to solve for the molarity. So let's go ahead and do exactly what I just said. So 0.150 moles of our sulfuric acid per, and I'm just going to do it in milliliters, 1,000 milliliters, times, and we want to cancel out our liters, our milliliters here, so 10 milliliters of that, of our H2SO4 over 1. Just a placeholder 1. And then our milliliters amount here is going to cancel out with our milliliters amount here. We'll be left in moles of sulfuric acid. Well, we know from our balanced equation for every 1 mole of sulfuric acid, so just 1 here, we require 2 moles of our sodium hydroxide, 2 moles of NaOH. So now our molar amount is going to cancel out here with our molar amount up here, and we're left in moles of sodium hydroxide. But we want molarity of sodium hydroxide, so we take this one step further, utilizing our volume amount here. So we could do it one of 2 ways. We could convert this directly into liters, so this would be 0.02537 liters, and we know that because we just move our decimal places 3 times because that's what milli means, so 1, 2, 3 would give us our correct 1 in liters, or you could do it 2 steps. So you could do it 25.37 milliliters over 1, but we know molarity is always in moles per volume, so every 1,000 milliliters is 1 liter. Really, it's up to you. And then you just plug and chug all of these values, and you'll be left in, because our milliliters here will cancel with milliliters here, and we'll be left in moles per liter, which is a molarity value or a concentration value. So let's go ahead and plug and chug. 0.15 times 10 times 2 times 1,000, all over 1,000 times 25.37. And you are going to get, for your answer, 0.1183 molarity for our sodium hydroxide. And that will be your answer. All right, let's do this last one here. Okay. Calculate the grams of magnesium carbonate that will react with 70 milliliters of 0.201 molar phosphoric acid. And once again, we are given this very key piece of information, which is our balanced equation. Now, let's read that one more time. We're trying to find the grams amount of magnesium carbonate. So when we know that at some point we're going to have calculated our molar amount then, our moles amount, which we can utilize from our balanced equation. So once again, our phosphoric acid gives us 2 key pieces of information. So we'll start with that, with our molar amount in the top. So 0.2010 moles of our phosphoric acid all over. And once again, I'm just going to put this in 1,000 milliliters, so it's an easy conversion, times, and we were given 70.00 milliliters of our phosphoric acid. So now, do that over placeholder 1. Milliliters will cancel out with milliliters. Next step. We want to utilize our balanced equation to solve for our moles of magnesium carbonate. And that is going to be for every 2 moles of our phosphoric acid, we're given 3 moles of our magnesium carbonate. So for every 2 moles of our phosphoric acid, and we put it in the bottom because we want it to cancel with our denominator here, with our numerator here, and then we are given 3 moles of our magnesium carbonate in top. So now we are left in units of moles of magnesium carbonate, but we need to take this one more step because we want to solve for the mass, the grams of magnesium carbonate. So once again, we are going to utilize our periodic table to solve for our molar mass. So that's just going to be, once again, that 24.3 for magnesium, plus essentially 12 for our carbon, plus 3 times this 16 value for our oxygen. And we are going to get a molar mass. So for every 1 mole of our MgCO3, we are given 84.3 grams of our magnesium carbonate. And we will be left in units of grams of magnesium carbonate, and that will be our answer. So plug and chug. 0.201 times 70 times 3 times 84.3 all over 1,000 times 2, and we are given a value of 1.78 grams of magnesium carbonate, and that will be your answer. So this is just some examples of some solution chemistry that we've been going over the past several weeks that will be present on your exam. I hope it makes sense. As always, if you have any question, feel free to email me, and you guys are going to ace your second general chemistry exam.